All right, I am working on some more writing and naming formula problems. So this is just a continuation from Module 6, Lesson 2. Everyone needs to watch the first little bit of this because I forgot to tell you the exceptions in the last video. That's my bad. But then after that, I'm just going to work some more writing and naming formula problems for you. And if you need help, you can continue to watch. And if you don't, then we can cut it off after this. So here's the part that everybody needs to pay attention to for just a minute. I told you on our last video for this that there are some exceptions in the periodic table to our Roman numerals. Remember, we know that our groups, our A groups, our representative groups, like 1 through 8A, they do not need a Roman numeral when you're naming them because you know how many valence electrons they have. So there are two exceptions to that, and they are tin and lead. They fall right here. Here's tin and lead. They are in an A group. So you wouldn't think that they would need a Roman numeral. Well, this is why they're an exception. They need a Roman numeral because they can have more than one valence electron number. They can either have a 2 or a 4. So you have no way of knowing if it is a tin-2 or a lead-2 or a tin-4 or a lead-4 ion unless you are given the Roman numeral with it. So if you see these, then they have to have a Roman numeral. Now, we also know, I went the wrong way, that the B group right here, these B elements, they need Roman numerals because that's the only way to know how many valence electrons they have. There are 3 exceptions to this. It's zinc, silver, and cadmium. And this is just basic knowledge. The final exam, the released questions from years past, they like to ask these exceptions to see if you know them. You need to memorize that silver is a +1 and that cadmium and zinc are +2s. They do not get a Roman numeral, even though you would think that they would. I forgot the word Roman there. Talking and writing don't go too well together. So that's why these are exceptions, is because you have to memorize that. So for example, if you were going to name this right here, you would simply call it silver chloride. You would not call it silver 1 chloride. Now, most of my students have trouble remembering these Roman numerals. That's one of the things that they struggle with the most, and therefore I have quite a few practice problems for you. There's 98 of these that you can try. I'm going to request that you try only a portion of them, so read the information on this part of the practice assignment to see how many you have to do. I will not count the 8 that I'm doing right now as your work. So let's just go at this and see kind of how it works. This is what it would normally look like instead of your other practice problems. So if we are going to write the names of these things, we're going to employ what we've learned so far. And someone upstairs or outside has decided, I thought someone was vacuuming, but I think they're mowing the yard, so you get to listen to that in the background. All you do is you name the ions. So I recognize with this that there are 3 capital letters. So what does that tell me? It tells me that somewhere along the way there's a polyatomic ion in this. And remember, you have a polyatomic ion table. If I still have mine open, I do. It's right here. Right here's your polyatomic ion table. Polyatomic ions are most often the things that are on the right-hand side. So let's see if we find ClO3. Sure enough, I see it right here. It's called chlorate. So what I do is I name the first one. K is called potassium. And the ClO3 is called chlorate. That's all we're doing. We're just naming. Number 2, iron and iodine. Okay, I don't see 3 elements, so these are going to be just the names off of the periodic table. So if we look back, we'll see that iron is down here in the section that needs a Roman numeral. And it's not one of the exceptions. So how do we do that when we're working backwards? Like, I've not given you your problems like you had before where you had to draw them out. My suggestion is to draw it out. We know that there's 1 iron with 3 iodines, right? We know how many iodine needs. We know that each iodine is a -1. And if this one iron is able to cancel that out, then that means that this iron has to be a +3. We're just working backwards. So this is going to be iron 3 iodide. Now, why did I switch the ending of this one to "ide"? Because it came off of the periodic table, not the polyatomic ion table. All right, number 3, lithium and oxygen. Lithium, it's an A element, so I don't have to worry about this Roman numeral thing. We just name it lithium and change the ending of oxygen to "ide" because it's coming off the regular periodic table, so it's lithium oxide. Beautiful. Gold and fluorine. Find gold. It's right here. It is close to our exceptions, but it's not one. Gold is one of the B elements down here, one of the B groups. So what that means is it does need a Roman numeral. So by the same token as the last one, work it out. You have 3 fluorines. They each have a -1 charge. That gold has to be a +3 to cancel it out. So this is called gold 3 fluoride. All right. Number 25 up here. Oh, I see 3 capital letters. So when I see 3 capital letters, that tells me that there's a polyatomic ion. And most polyatomic ions have have oxygen in them. So most likely it's this NO3. So let's go look. Let's flip over here. And NO3, sure enough, is right here. Right here's our nitrate is what it's called. So we know that it's going to end in nitrate. So what about this iron? Well, we just did iron over here. Iron has to have a Roman numeral. What was nitrate's charge? Okay, this is a -1. I don't like the way your reference table looks. The 3 is down to the bottom and the negative is up top. The negative has an understood 1 that goes with it. It is not a 3 negative. So if there's 1 iron and 1 nitrate, then that's going to be iron 1 nitrate. Okay, K and F. Potassium's right here. It's an A group. It's a representative group, so I don't need any Roman numerals, no extra work. So this is called potassium and fluoride. Okay. CrCl2. Whoops, wrong way. Where's my Cr? Cr is right here. It's part of the B elements. That means it needs a Roman numeral. So you could work it out. You've got Cr and 2 Cls. Each Cl has a -1. I'm figuring that out off of the periodic table. If there's 1 chromium, that means it's got to be a +2 to cancel out 2 -1s. So we name it chromium 2 chloride. And if you're still with me at this point, by the way, like you get to use this reference table when you take a test. So you should have the polyatomic ions in front of you. That is totally allowed. Okay, this one. Let's find Sr. Sr is over here. It's a group A element. So no funky stuff. Just name it. Strontium and then iodide. So I'm using the number of elements to help me. If it's got more than 2 capital letters, something is a polyatomic ion. And I'm also checking my periodic table each time to see if I have a transition element that needs a Roman numeral to go with it. All right, let's look down here at these. These are where you had to write the formulas. I like this better personally. It's faster in my opinion. I just did all of these for your answer key and thought my hand would fall off, so I do feel your pain. I'm not making you work all of them. All right, so some of you can do this in your head, and some of you need to write it out. I'm writing it out for those of you that need it. 10-2. Now, this is one of our new exceptions. And if you're looking at the reference table, you're going to say, but Miss Houston, 10 is in group 4. Doesn't it have 4? Not always. That's why 10 needs a Roman numeral. It's a +2, and it's going with fluorine, which is a -1. It'll take 2 fluorines to cancel that out. So it's SnF2. Zinc sulfite. Okay, some of you are going to look at your reference table and you're going to go, but zinc is a B. I don't know how many that is. How am I supposed to do it? Well, I told you you're supposed to memorize it. Zinc is a +2. You're expected to know this. All right, pay attention to this too. This ends in ite, I-T-E. That's different from IDE. Your polyatomic ions end in ite and ate. You see that over here? Ate, ite, ite, ite. You have hydroxide. That is the only one that I am familiar with that commonly ends in ide, and cyanide. And then you have ammonium. 3 of these do not end in ite or ate, but all of the rest of them do. So when you see that sulfite is not sulfur, it is sulfite. It's this right here. It's SO3 with a 2 negative charge. So it's SO3 with a negative 2 charge. Well, I don't care if it's a group. I have a +2 and a -2. What they do is they cancel each other out. So it's ZnSO3. Very good. Okay, cadmium oxide. Cadmium's here. Oh, look, it's one of our other exceptions. You're supposed to know this one. Cadmium is a +2. How do you know? I told you to memorize it. Oxygen's a -2 because it's in group, oops, I keep going the wrong way. It's in group 6, and it's going to gain 2 more electrons, making it a -2. They cancel each other out. So we simply write down CdO. Okay, silver hydroxide. Man, I'm just hammering home the exceptions here. Silver was another exception that you were supposed to memorize as a +1. Hydroxide. Now, some of you are going to fall for the ide. Now, when you look this whole table over, this is not called hydroxide. This would be called hydride. And it's not oxide because it's got the hydr in front of it. So you know where you go for hydroxide? This polyatomic ion table right here. It is OH minus. The minus means it has a -1 charge, +1, -1. They balance each other out, so it's AgOH. Potassium phosphide. Okay, well, this ends in ide. This is just plain old phosphorus. So potassium, if you go to your reference table, is a +1. Phosphorus is here. It's in group 5. It needs 3 more electrons. I know that because it's a nonmetal and I've memorized all this stuff. So that'll be a -3. It'll take 3 of these to cancel that out. So it'll be K3P. I think my pen is dying again. Sodium and nitride. Sodium is a +1. Nitrogen is right up above phosphorus. So it'll be a -3 as well. So that'll be Na3N. Magnesium is a +2. It's in group 2 and metals lose, so it'll be +2. Chlorite, I-C-I-T-E. That means it's on this. Chlorite is right here. It is ClO2 with a negative charge. So ClO2 with a negative charge. They do not cancel each other out. A +2 and a -1. I'm going to need 2 of these to cancel out that 2. So we'll start with the Mg. Now, if I'm going to have 2 of these, don't forget I have to have parentheses so that it doesn't look like Cl and 22 O's. You have parentheses around them only when there's more than one. I didn't put parentheses around the sulfite, and I didn't put parentheses around the hydroxide because I don't have more than one of those. Last but not least is silver bromide. You were asked to memorize the silver. The bromide is a -1. It's in group 7, which means it'll gain 1 more since it's a nonmetal. Okay, they balance each other out, so we have AgBr. Now, my experience with this is that the more you practice this, the better you become. And when you don't get it right, you need to figure out what you missed. Most of my face-to-face students, the thing that kicks them in the teeth as they do this is forgetting when they need to give the Roman numerals. So they'll do everything else correctly, but they'll call this iron oxide or iron iodide, gold fluoride, iron nitrate, and they forget the Roman numerals, and that makes it wrong. So please don't forget those. All right, go to your practice assignment and finish up.